Hello again. I wanted to talk about the physical aspects of the two-tube Autodyne receiver. We've been going over this receiver in the last two videos. The way that I constructed this receiver is probably not true to the way that it was meant to be constructed as a beginner's receiver. It's much too restrictive, being only a one-band receiver. This receiver tunes a very limited segment from 7 megahertz to about 7.2 megahertz. In reality, most starting hams wanted to be able to cover more than one band so that they could not only pick up ham bands but some shortwave bands in between, practice code on 80 meters, 40 meters, and perhaps listen into some of the action on 20 meters, some of the DX action. In order to change bands easily, the most common device that was used with these receivers was called the plug-in coil. This is a plug-in coil, typical manufactured plug-in coil made of a bakelite substance. This one's made by Hammerland. Here's a little bit later plug-in coil. This one is phenolic. As you can see, hams sometimes resorted to using the bases of tubes as plug-in coils. So here's a very abbreviated plug-in coil. Looks like it's got enough turns to perhaps cover 40 meters. So that's pretty clever. Now in my single band situation, I wanted to get maximum performance with the receiver. So I wanted a coil that had more stability and covered the band of interest with the most Q. This would allow me to have the most selectivity in the receiver. I mentioned that I had a variable coupling control on the front of the receiver. This is a very important control. It turns out to be the secret behind this receiver being so effective on the band. So let me try to get a picture of what that coupling network looks like. This is the tank coil. It's made of number 14 enameled wire on a PVC form. Now if I had been able to find a form of ceramic, I would have used that, but the PVC has good Q. The input link that comes from the antenna is on this side. This is the Faraday Shield. I don't know if you can see that, but it's a shield that's made of aluminum, and it's like the teeth of a comb. Only the bottom of the comb is grounded. As I loosen the coupling, note how the coil literally moves away from the tank. And when it's completely away from the tank, we get about 40 to 45 dB of attenuation. So that is how the coupling control works. It goes back and forth, full coupling, minimum coupling. And this is sometimes called a lift link system. That is an untuned link that goes to the antenna, and it's lifting off the tank. So that is a lift link system. Notice how the vernier is attached to a small band spread capacitor, and it's attached directly to the front panel. As the front panel flexes, the entire assembly moves with it, thus reducing any mechanical instability. This capacitor is a fixed capacitor that sets the band. As you can see, it's almost fully meshed, and this is the situation that you'd like for most stability. You'd like to have as much capacitance in this fixed capacitor and just do the tuning with the smaller two-plate band spread capacitor. Let's look at a couple typical verniers that you could use on a regenerative receiver. The first one is an antique vernier. This is something from the 20s and 30s. You see these sometimes for sale at hamfests. They work very well for regenerative sets, and they're quite good verniers. This is a National velvet vernier. This can be adapted into many different uses. This is an excellent vernier system. for regenerative receivers. Variable capacitors. This is the typical capacitor used in an AM type hobby regen. It's a 0 to 365 puff cap, single section. Compare that to the quality of this all brass design. This is a pilot. This is from the 1920s, early 30s. Much more rugged design. It's going to give a lot better performance. Here's another likely band spread capacitor, just a couple of plates. That's providing me with the band spread function that I need. We might talk about ceramic tube sockets versus phenolic or plastic. I have seen no difference. Both seem to work just fine in the regenerative circuits. We went over some tubes last time. This is a 6J7 glass tube. The grid is on top. That makes these a little bit harder to use. Here's the 6J7 in metal with an integral shield. Both of those are excellent tubes for the regen detector. But remember, the grid is hot. So when you go to the grid leak off of this tip, you have to make sure that's as short as possible going over to the tank. And some people even resort to putting a hood over that assembly to give it a little more rejection from hum. This tube type morphed into the 6SJ7, 6SK7 type of tube, where the grid comes down into the base. It's a little more stable situation now that we don't have to worry about that tip. Does it work better? Hard to say. Some people still think that the grid cap on top is the superior situation. Now in miniatures, and miniatures are actually easier to find, I think. Here's a little ceramic socket and a nice tube shield that goes on it. Perhaps a miniature version of this receiver would use a 6AU6 and a 6AV6 as a tube lineup. The detector certainly would like a shield like this on it for best performance. Starting with a metal design, a metal chassis with a thick metal front cover. Notice I've got a brace on it, so there's no movement at all. This could be put into a larger enclosure, all metal, and it would just improve stability. We should talk a little bit about power supplies. Since regenerative receivers don't use a lot of power, of course some of them were run on batteries years ago. B batteries are kind of hard to find now, so you will need some type of AC supply. Here's a typical supply. This is actually overkill. It's a 5Y3 tube, a choke, and a small transformer. Certainly a regenerative receiver power supply should not be any bigger than something like this. Finally, we should probably talk about the antenna that you'd use for regenerative receivers. Regen is so sensitive that you don't need to have a large antenna. Perhaps a 50-foot long wire would be adequate for the regen. If you're going to use a dipole, a 40-meter dipole, that is a dipole with 33 feet of wire on each leg, is a wonderful place, especially if you're interested in the 40, 60-meter band, 49-meter shortwave band, and so on. So I hope some of these ideas of construction and picking components that are solid rather than low-cost components, and focusing on the parts of the receiver that promote stability and the ability to handle signals have helped you in designing your next regenerative receiver.